The following program addresses some of the problems associated with the exposure of inexperienced pilots, both helicopter and fixed wing, to the relatively critical operating limitations of the gas turbine engine, particularly during the start-up procedure, but also during shutdown. The expense and downtime resulting from an error in engine handling are avoidable if the correct procedures and limitations are followed. Those procedures and limitations will differ according to the aircraft type and engine involved. Later in the program we will also look briefly at the problem of an in-flight flameout. The temperature of the exhaust gases in a gas turbine engine should always be closely monitored, especially during the start cycle when overheat damage is most prevalent. There are various gauges. TIT, turbine inlet temperature, is considered the most critical of all engine operating parameters because an out-of-limits condition can render the engine unairworthy in a matter of seconds. ITT, interstage turbine temperature, which refers to the temperature reading taken at some interstage between turbine wheels and is also a critical gauge. TOT, turbine outlet temperature. EGT, exhaust gas temperature, and T4, temperature fourth stage, are all various means of measuring and monitoring basically the same parameter and are also critical gauges. The temperature of the exhaust gases, no matter how they are measured or displayed, indicates the integrity of the turbine components more than any other engine instrument system. In both the normal and motoring start, you will have noticed the temperature peak before dropping back and stabilizing. The difference between the peak temperature reached during both starts and the maximum allowed is less than 300 degrees centigrade. It is essential, therefore, that the TOT and N1 gauges are closely monitored during the start cycle. A hot start is a condition in which a gas turbine engine starts, but its internal temperature rises high enough to damage the engine. It can be caused by a lag in acceleration or restriction to airflow. The lag may be the result of a number of things: foreground power source, misalignment of guide vanes, or a strong tailwind allowing exhaust return flow in the nacelle. It may be recognized by a rapid ITT or TOT increase, a slow increase of N1 or NG, or even exhaust flames. Throttle, close to idle cutoff. Carry out a motoring cycle until TOT, turbine outlet temperature, is below 150 degrees centigrade. Our second example of a hot start is on a Saab 340A. The NG is rising. ITT rising quickly. Fuel is shut off. Ignition switch is off. By carrying out a motoring cycle, the temperature is reduced to an acceptable level. As can be seen from both examples, it is essential that the pilot attentively monitor the start cycle to ensure prompt action in the event of a hot start. Inattentiveness or becoming distracted could prove extremely costly.